Alrighty.
Yeah.
Yeah. Is the microphone working?
Yeah.
Cool.
Hi everyone.
I'm Duff. This is Punk. So-
Exactly.
yeah. All right. Okay. So yeah. Welcome to Angular and React friends learning from each other. So obviously this talk is about Angular and React, and so today what we want to do is we want to show you some things you can do in React, and then some things you can do in Angular. And basically the idea is that we can all learn how things are actually being done in different frameworks. So one thing we want to clarify up front is, so you might wonder, is this yet another versus talk? And we want to make very, very clear that this is not a versus talk. So we are not comparing the frameworks in the sense of which one is better, right? Which one is better? Which one is faster? We really want to rather take the time to explore, how things are done in different frameworks and how we can learn from each other. So this is really not another versus talk. Really, we want to make that very clear. In fact, it turns out that people are saying that when they learned React, it's much easier for them to actually understand how Angular 2 works, or to get the concepts, the ideas behind some APIs and structures and everything, which is pretty cool, right? So if we can learn from each other, then it's for both sides, it's very good. And also, there are even people saying that Angular version 2 and plus is actually closer to React than to Angular 1. So that's also very interesting.
And I've reached my career goals, so someone cites me in their slides, even though those are my own slides, but then at least someone did it.
Right. Okay, so what we want to do today is we want to explore, we want to take a look at 3 different scenarios that we think are going to be very common in the world of web development, in the front end specifically, when we build apps with either React or Angular. So we're going to take a look at runtime performance tuning. So what can we do? What are the tools that we have to make our app faster? And again, this is really not comparing in the sense of who is faster, but really just what can I do in this framework to make a thing faster, and how much effort does it take to make it work. The second scenario is server-side rendering, which is apparently a thing in Angular, as we all know, and also in React. So we're going to take a look at that. And then we also want to take a look at how easy it is to integrate a third-party library in React or into Angular. So how much work is needed to make that work. And so, yeah, I think we can start right away with runtime performance. So we have this this demo, which is not really like a real-world use case. It's more like really like a demo to demonstrate and visualize performance improvements. So the idea is that we render 5,000 SVG boxes, which are draggable. So basically, it looks something like this. I have the demo right here. So I can click a box. You can see here we're dragging and it works. This is the vanilla version. This is vanilla JavaScript. This is no Angular, no React here. And to give you an idea of what the code looks like, so we basically have an SVG element, and what we need to do is we need to render a couple of rect elements, right? So those are the square boxes. And then they get some X and Y positions, which are randomly generated. And so then what we have is a function drawbox, which basically creates these rect elements, and then they get their attributes X and Y dynamically assigned. And we call this function basically a couple of times. So we have some sort of amount that we want to render. In our case, it's 5,000 boxes. So we have this loop right here, and then we basically generate 5,000 different positions for these boxes, and then we draw them. And then last but not least, what we do is we call this function create boxes so that we actually generate these boxes. And then what we do is we basically attach some event handlers to that SVG element where the drag and drop stuff is happening. And really the only, the actual interesting part in the event handler here is the mouse move event, because that is the one that actually takes care of of updating the box, right? So as you're dragging, X and Y are being updated. So we can see here that we get the current box, we have the event, and then we assign X and Y and calculate the new position. Okay, cool. So that's the baseline. Let's take a look at what that looks like in React.
Right. So first to start off, I designed this application to make it as hard as possible for any framework to perform well. So if you see slow behavior, don't be surprised. It can never be as fast as the vanilla version in this special scenario. It is not a very practical example. You have just 5,000 elements in your model, and that is a flat model. That is the worst you can get. So we did it by like on purpose to make it as hard as possible. So first, the React version. So in the constructor of that just normal class, you create the boxes. You could create them outside. And the special thing about React is you cannot just use properties of any kind, but you have to use a special property that's called state. And what you put in is, by definition, the state of that app. So the most important function is the render function. React renders by calling a function. There's no external notion of a template. There isn't even a template language. There is something that looks like a template language, but we will see that. And this is just, the next line is just destructuring, taking the boxes from the state. I put it in before. And then returning something like this that looks like HTML, but it's actually like a very thin layer over JavaScript. And this is very similar to the vanilla version. So I have an SVG element, and as in the vanilla version, I register the mouse listeners just on the very top. So I don't have one listener per box, but one per SVG. And then down here, I just use those boxes, and this is something you have to get used to in React. You just write some JavaScript to render those boxes. And this box thing here, this is just a subcomponent. And the subcomponent looks like this. Again, it's a React component. It again has a render function. It doesn't have any state. So it's same as in Angular. You have the smart components, which was the component before. This is a dumb component. And again, I'm taking the boxes from something called properties that would be input in Angular 2. And I'm creating a rectangle. Easy thing. The important thing is on mouse move. Again, very similar to the vanilla version. I know what is the current box. I get it out. I update the offset, and what I always have to do is set state. So this is triggering React re-rendering. Okay, and this is how it looks like.
Right.
And don't be like
it's gonna be laggy.
Yeah, it's gonna be laggy.
It's gonna be
so
intentionally
you did
laggy.
it on purpose.
So this is basically the same demo built with React. So I can drag a box like this. You see it's lagging, right? Just to give you like some idea, and those numbers don't really matter at this point. We just want to use them as to get some relation and the improvement that we're going to do in a second. So I just made a profile, and when we take a look at the mouse move event, it takes about 30 milliseconds. Sometimes 44 milliseconds, sometimes 30 again, or 32. So this is about the time it takes to perform this event every time we drag the box.
Right. So to understand why it takes so long and what we can do about it, we have to understand how React actually does render and how it does change detection. So every mouse move, like every move event, triggers a full re-render of all 5,000 boxes, which must be super slow, but it comes with a catch. It only renders it in the so-called virtual DOM. So there's a lightweight version of the DOM that React renders to, and then it compares the new version after the event of the virtual DOM to the old version. And only the difference will be actually affect the real DOM. So DOM updates are very small, like not many, but with each mouse move event, it has to fully recompute the virtual DOM, and it's quite big. So that makes it slow. But there's something you can do about it, and there's a lifecycle hook. Same thing in React as in Angular, lifecycle hooks, and that lifecycle hook is should component update, and this is the method that gets called from the framework to ask the component, do you think you should be updated or not? And if you do this, it gives us the control, should we do it or not? And if you use immutable data structures, again, exactly the same as with onPush. Pascal is going to talk about later. So exactly the same as in Angular 2 or Angular. we can tweak this a little bit. And this is the mouse move thing. And you might notice that there's a tiny little change to the first version. In this case, I'm creating a new object. And this is like a very cheesy and a low-cost version of immutable objects, more or less. So I'm creating
because you're getting a new reference in that case, right?
Right. So it's about getting a new reference and not updating something. Okay. And now, this is again the box component. The most important part is I'm adding this lifecycle method here, and the check is trivial. So I'm getting in the new, or the next properties called next properties, and I compare them to the current properties. And I'm interested in the box property, and if they are equal, I can be very sure they should not be updated. If they're not equal, I can be very sure it should be updated. And this brings us to this performance.
Right. So this is, again, the same demo built with React, this time using should component update. So I'm going to drag a box here. You see it's already a little bit faster. And just to get some numbers, again, the number itself doesn't really matter, more the relation, like the difference between the other numbers that we've seen before. Once the timeline is loaded, there are a couple of other things running on my machine. Also something to keep in mind, right? So these numbers are kind of affected by the fact that I have servers running right now, and so those are not really numbers you want to use to measure really. So you see again like 40 milliseconds, but then we have 30, we have 80 milliseconds, 20 milliseconds for mouse move. So there is in fact an improvement going on here, right? I think the nice thing here is that it really just took like this one little function.
Yeah, right, just this. And then tiny change of how I update my model. So low cost, almost twice as fast. Okay.
Cool, let's take a look at Angular. So what would we do? I think this is pretty cool, should component update. Let's see what we have. So let's take a look at the Angular implementation. So this is the Angular component. You all know what a component Angular 2 looks like, right? We have a template with the SVG element. We have the event handlers registered, so mouse down, mouse up, mouse move. It's essentially the same algorithm implemented here. And also the logic that is used to create the boxes and everything, this is all essentially the same. The only thing that we don't have in Angular is this thing called state that we need to update every time. Because in Angular, we can just write to the properties of the component, and it somehow magically knows that it has to re-render stuff due to its great change detection and zones. But anyway, so we have this other element here, which we generate a couple of times. So we have this ng4, and for every box that we had generated in the component, we basically render this element here. So these boxes, those are, again, our 5,000 boxes. One interesting thing to note here is that, first of all, we have an input property binding going on here called box. So we pass every box iterator to that component. Now you might wonder, where is the component? Because this is just an SVG element. Well, it turns out there's a directive applied to this element called squarebox, and this one is in fact also a component. And you can see with the selector that this one actually matches that particular element because it has the attribute CSS selector for squarebox. So this is our box component, the one basically the equivalent to the one that we've seen in the React example. And here we basically we take the input box property that we bind to, and then we assign the y and x properties to the rect element, which again just renders that square box in the SVG. Okay, cool. So let's take a look at the demo again. So this here is the version Angular, and I'm going to drag a box, and you see it's laggy. Let's take a look at just some numbers. Because it actually turns out that sometimes it feels slower, sometimes it feels faster, and then the numbers actually tell you what's going on. So here we see mouse move takes about 35 milliseconds, 35 milliseconds, what else? 38, sometimes 33. Okay, so we kind of get a feeling, right? Okay, cool. So that's Angular, the Angular version. So it turns out that the Angular version is about as fast as the React version, the unoptimized one. So they're about as the same, at least measuring these demos on my machine, on this MacBook Air, and the numbers might be different on different machines. So keep that in mind. However, we still can improve this example because this is in Angular. Angular basically checks every component every single time there's an event happening. So in other words, there are 5,000 boxes plus the root component that needs to be checked. whenever there's an event happening. And when is an event happening in this demo? Well, whenever we drag the box. So whenever we drag, there are 5,000 boxes being checked by Angular. I think this is still pretty incredible that it is laggy, but it's I think for 5,000 boxes that it has to check, it's actually pretty okay then. But we can make it faster. So there's this thing called change detection strategy, which we can actually configure on every single component that we have. Because in every component, there's this change detection reference that we have kind of access to and that we can configure so that the change detection strategy is changed for that particular component. And so what it does is, or basically what we can do here is there's a strategy called onPush, and we can configure our component to use that strategy. And this will cause the change detection mechanism to skip the subtree of that particular component if there are no changes in the input. So if you think of our box component, it takes a box as an input. If there's no change in it, it will skip the change detection for the view of that box. And this works great with immutable data structures, because what does a change mean? Well, Angular basically compares changes by using like identity check if it's the same reference or not. And so basically it's kind of the same like what Oliver did in his React version. So we want to use immutable data structures for that. So what does the change look like? Well, this is our box component here, and all we have to do is we basically configure the change detection strategy to be on push. That's it. Let's take a look at the demo of this one. So there's still some tracking here. Oh no, it's actually this demo here. So this is the Angular version, same code using on push. So I'm going to track like this. And we'll see once the timeline here is loaded. My machine is not the fastest one. So we have some numbers like 19 milliseconds, 23 milliseconds, 90 milliseconds. So it is indeed faster. Pretty cool. Nice. So so the result is with onPush in this particular demo, we can save 8 bindings per box. This is because we have 8 bindings in the view. And another thing to keep in mind is onPush, it skips the subtree of a component. So it actually really is really powerful when you have a nested component tree that has like many levels deep. Then you can actually save like a lot of performance. In this case, we will have a flat tree, so we only get 8 bindings per box. But with 5,000 boxes, that's actually a lot of time that we can save.
Yes, so keep in mind that the typical application, like in the model of a typical application, it's highly segmented and then partitioned, and it brings much more. But still, with this thing, that it is as hard for the framework as possible, we still get almost double the speed, right?
Right.
So there's a lot you can achieve by that.
Another thing to keep in mind, actually, this particular demo, the two that we've now compared, are not very fair, because it turns out that ng4, the thing that we use to iterate over all these boxes, does actually a little bit of more work than Angular, than React's for each loop or whatever is used to generate the 5,000 boxes. Because ng4 keeps track of all the positions of our entire list. So if there's an item moving inside of that list, it has to keep track of that and then updates the DOM accordingly. Whereas the React version actually only checks for the length of the collection. So if we want to have a fair comparison, we actually would need to implement something like a simple ng4, which really only checks the length of the collection, if it has changed or not. So then we can save a little bit of more time. But on the other hand, this is a bit more effort, because you would need to implement that thing as a directive, as it's not provided by core yet. So, what do you say?
Yes, so observations, again, as the unoptimized versions, comparable speed up. Both can be optimized with very little effort. More optimization is possible. Pascal has something in the pipe for Angular. I did something for React where I artificially segmented the model in React, but it got so complicated, it was full of bugs. So I don't recommend that unless you are, probably you don't do it anyway, but unless you are really the last resort. And again, it's not about who's faster. It's just to show you how can you speed up things. And again, let me repeat it. This is a very non-natural model that we created. It was just a mean model, right? So
it's about being harder, better, faster, stronger.
Yes. Okay.
Right. Next topic, server-side rendering. So what does that look like in both frameworks? So why do we want to do server-side rendering? I think the motivations are kind of clear. What we want to do is we want to have fast page load, so when the user comes to our application, it should be there instantly, if possible. It is good for our application when it renders on the server side, so we can take advantage of things like social media previews. So when you share links on social media platforms, you see the previews with images and metadata and everything. This is not really possible when you have a client-side application that is not server-side rendered. And of course, you want to have you want to take advantage of search engine optimizations, and you need to render on the server side for that as well. Another thing that is actually nice about rendering the application on the server side is you get all the nice things like faster page load, SEO optimizations, and all these kind of things. Plus, you can actually share your application code on both environments. At least that's how it should be, right? So the challenges with this is that first of all, we need to find out how do we make the framework universal? How do we make it run on the server? How do we get the state from the server-side rendered application to the client? Because the client-side application needs to kind of bootstrap as well. And then we also want to make sure that the application doesn't flicker, right?
Mm-hmm.
Okay. So basically what we mean is something like this here. When we have a single-page application, you can see that it kind of builds up in the client. So in Angular, you see this loading or whatever, and then you see the page. When you have a universal app, you should instantly get a result.
So just to emphasize on this, in case you're not familiar with this view, this is from the developer tools in Chrome, and you can make snapshots every time something drastically changes. And this snapshot here is like the first rendering of the single page application is empty, because you get an empty page and then you load the JavaScript, it gets executed, it creates the boxes. And this is for the universal app where you have pre-rendered the whole thing on the server. It takes a little bit longer because you did all the work in the server, but it's there just more or less instantly, which is good for SEO, right? So if the Google bot comes around and tries to look what's in your page, it finds it. So, and you get the impression that the application is much faster, even though in this case it's just 200 milliseconds, but it doesn't flicker, it's just there. Right.
Okay, so what does it look like in React?
So first of all, you need a JavaScript server for that. I mean, because if you want to execute JavaScript on the server, well, there you go. And the code that you actually have to implement on top, it's incredibly simple. It's almost stupid. I mean, in this case, I implemented something using Express, the standard stuff. There's a single route, this one, and when it gets a request, it renders the app, this thing, it tells it 5,000 boxes and sends back the result. How does that look like? I mean, how does it render it? Same thing. Create the boxes. After boxes, that is the model. I put it in the React component, same thing. And then there's something called render to string, which does what it says. So you have a React component, you render it to a string. So this is of type string, and this is what I return. So render page does something else. You see it uses the pre-rendered HTML, and at the same time it takes the boxes. It also takes the model. And this is because it has to transfer both the model as well as the pre-rendered stuff. And this is how the template might look like. It actually does. It's exactly our template. In this thing here, it creates the pre-rendered HTML. And in this thing here, it looks very simple, and actually is. This is the data that came in, like the boxes. We serialize it into JSON and just put it into a global variable for the client later to pick it up. So this is the client side. That was server side. Now we transferred. Now client side. Now the client has to do something with the stuff. And it takes this thing out, puts it in here. This is just, again, stupid code. And then it calls the typical bootstrap process of React down here. And what it does then, it checks if something has changed. And if it did not check that, it would flicker. And it works by checking checksums. So that might be a bit fast now, but this is like rendered sample. This is the pre-rendered HTML coming from the server. This is the state encoded in a script block. Hopefully you can see that from behind. And this thing here is interesting in that example. It's called data React checksum, and it contains a number. And what React does, it takes like the code, it renders the virtual DOM, and it creates a checksum using the sum algorithm as the server did, and it compares those two checksums. And if they happen to be identical, it does not re-render. That means it doesn't flicker. That's pretty simple, and you don't have to do anything. Maybe give us a short demo.
Right. So this is the universal rendered React app. Let me
It's a little bit
reload.
boring, right?
Let me reload real quick. So you can see it looks like it's not instantly, but it actually is. It just takes a bit for the browser to render all these 5,000 boxes. That's what
Can
we
you
have.
drag and drop a little bit now?
Oh, sure, of course. This looks faster now because this actually has the segmentation code in it.
No, I removed it.
Oh, are you
I
sure?
think it's because the browser tools are no longer open.
I think it's in there,
No, it's not.
but we'll check later.
Yes, you can. So no matter what, the interesting part is all the code that that was 100% of the code that I used to make this work. So the cool stuff about it starts as a server rendered classic web application, and once it is in the browser, it continues as a single page application. And that is like the mind-blowing thing. You get the benefits of the old school, if I may say so, web application, and then it continues as a single page application. And if this is something that you might need, it is that amount of code that you have to write.
Cool. Nice. That was pretty straightforward, right? So what does it look like in the Angular land? Well, so when we want to do server-side rendering in Angular, there's a bit of more work we need to do due to some APIs that Angular relies on. So Angular has this thing called ng module, right, which is basically a container of a application or part of your application that has a couple of things like directives and services and stuff. So this is basically the ng module of our current application that renders these boxes. So you see we have the app component, there's a square box component, we bootstrap the app component. And then one thing that is very important here is the thing that makes this particular module work in the browser is the fact that we actually import the browser module from Angular and add that to our ng module. So this is the module that comes with all the things that are needed to make our code work in the browser. So this is the browser, the client-side version. Now, what do we need to do to make this one work on the server? So for the server, we would actually use another ng module, right? It's just metadata after all. So this would be the node module ng module version. And you see it's actually kind of the same thing. The only thing that is really different is that instead of having the browser module imported to it, we are importing the common module and the universal module. So common module is the module that comes with directives like ng-for and ngIf and all the core and common directives. We don't have to do that in the browser-side version or the client-side version because the browser module already imports that common module and exports it again. So using the browser module implicitly uses also the common module. On the server side, there's no browser module we want to use, so we use explicitly the common module and then the universal module, which is an ng module, again, from the Angular Universal project, which is basically an effort to make Angular 2 or Angular 2 Plus work on the server side. And it comes with great things like engines for server-side JavaScript code, like Express and Happy.js and these kind of things. So that's one thing. We create another ng module. And then what we do is on the server side, we create our Express server. So it's pretty much the same thing. What is interesting, though, is that we use one of these engines. So Angular Universal provides an engine for Express.js. So we create an engine, we pass it our ng module. And the ng module we're passing in here is the one for the node side, right? So the node module TS file. And then we just render, whenever there's like a request coming at this point, we render the index.html. And this one actually pipes the request through the engine that we've created. This Express engine is kind of aware of Angular templates and knows how to compile them. So this is basically the thing that makes it work that Angular can render on the server side for this particular server implementation. Again, for Happy.js, there's a different engine. And then there's also pre-renderers if you want to do something like the React version. So how do we preserve the state? So now that we've basically rendered the application on the server side, we send it to the client. The client side bootstraps, and it regenerates the 5,000 boxes, which basically gives us different positions than the ones that we got from the server. So to do that, currently this is kind of in the works. So basically, what we do is in our server-side ng module, let's say we have a state service, which is just like a getter-setter service that we can like write to and then get some stuff out. We make that available to that ng module by adding a provider for it, and then we just inject it into the module. And then what Universal does is it gives us a lifecycle hook called Universal Do Dehydrate. I know that the name sounds scary, but the only thing it really does, it's there to give you an opportunity to send your server-side state to the client. And we do that like this. So in our case, we have our state service. We set the state from the boxes that we've created. So this is just normal JavaScript code, nothing special going on here. We then get the values, like the whole state of the service, as JSON, so we can stringify it and then write that to universal cache. So what is universal cache in this case? Universal cache is like an object that is made available in that lifecycle hook, and it's basically like a cache on the node side. On the client side, it's going to be the window object with like a global object on the window object that we can then access. So this basically writes the data or sends the data as string from that service to the client. On the client side, we can do the same thing. We add a provider to the module so that we have the service available in our application. We inject it into our module, and then what we can do is we access the universal cache on the window object from the state service, which is the values as like JSON. And what we then can do, we can basically kind of restore the state of the state service that we've generated on the server on the client side. And then again, this basically sets that state on the state service so that we can then go ahead in our like application and inject it there and use that state. So you might notice that using window as a global object and accessing it directly is not very nice. What we can do is we can just add the universal module to our client-side module as well, and then we actually get the universal cache as an injectable, which is pretty nice. The app then looks something like this. So this is the code that you use on the server side, but also on the client side. You just have the state service because you have a provider already implemented on both modules. You just inject the service. It has the state because it got it from the module code, and then you can just ask for the box state. And then this is what the application is initialized with. So to give you a demo really quick, this is server-side rendered. I refresh, and you can see you get your like initial page load instantly. Okay, cool. So observations.
You should say that. I don't want to say it.
You don't want to say that. you don't like Angular, huh?
No, I don't want to say it. It feels more verbose.
Okay.
That's up to you to judge. So
Okay, so it feels like we have a little bit more work to do actually to make it work on an Angular land, right? Because there's this thing called ng modules, which is like a bit more typing, but the cool thing about it is that we can basically use the same code on both sides, and we can at the same time take advantage of features like AOT, because that you can use on the server side as well, which works with ng modules because they give us context for the compiler, which is pretty cool. The trait transfer also requires a bit more effort, so we don't just write a string into the window object. Well, we do that essentially at some point, but at least we take advantage of DI. So this is also pretty cool, but again, a bit more work. What is also cool in Universal, in the Angular Universal project, you actually get providers or services in the Node version with like HTTP services that can work on the server side. So Universal takes care of making even your like AJAX requests and everything work on the server side and on the client side at the same time.
Nice. So React, I think it seems a little bit more simple, or I don't know, less sophisticated. I mean, the interesting part is also that if you want to use Web API on the server side, you use something called isomorphic. You cannot read it. I cannot read it either. Fetch, because this is the standard way of making server side calls from React. No, it doesn't help.
Okay.
Too bad.
Whatever.
But they still both get the job done, and I think the result is pretty comparable again.
Yeah, I think so too. Okay, we have one last thing to talk about, and we're running a bit out of time, so let's go on. Third-party library integration. We want to use something.
D3 libraries, charting. You don't want to write that yourself, at least not me. It would look
Bootstrap,
bad.
jQuery, all these
Also,
things.
yes.
It's all out there. You want to use it,
Yes.
but you don't want to rewrite it. So this is our demo here. We basically want to extend our example to do something like this, create a pie chart that basically tells us how many boxes are in the top right corner or the top left corner or the bottom right corner. And as we're dragging and dropping the boxes, you can see that this pie chart updates, right? So this is actually using a third-party library.
That's advanced, right? I mean, this is almost like, you want to buy?
So the challenges here are like questions we need to answer. How do we actually get access to the DOM in our components? Like, what's the way to get access to the DOM and work with these elements? Because we might need to do that. And also, how do we send updates to third-party libraries when there are changes?
Okay, again, first the React version. This is a component, a new component called chart. Again, the React component. Render method you already know. This is the template. Should component update is always false because this is now no longer on React to actually touch the component once it is rendered because our library does it. Component did mount, again, lifecycle method. It's probably, I'm not sure, ng init or after init, I'm not quite sure. What I do, I get the data out of the inputs and I calculate, I just pre-process it a little bit to make it digestible for the chart and then I render the chart. And the important part here is I get access to the underlying real DOM element, which are stored in this chart using this. This is how you do it. I mean, this is just, well, you get a callback once it is rendered, then this gets called, and then I store the reference, like the real DOM reference, because I need it, because this third-party library needs it. And this last thing, and that's it already, it will be called each time properties change, or each time the React would think now that it would be time for the component to update. Even though should component update is set to false, this gets called every time. And what I do, I take the new properties, I pass it in, I re-render the chart, or better to say, I updated it. And you saw the animation that shows you that the update actually happened. That's it. So this code here, of course, calculate data. It's somewhere, but this is not React specific. It could be the same code for Angular as well.
We're actually using the same code to calculate the data and the same code to render the chart. So we don't want to bug you with that. So the demo we have already seen that one, right? So this is this one here. We can like drag these boxes. You can see that it updates. It has nice animations. But again, the third-party library takes care of actually rendering that thing, right? Okay, cool. So in Angular, let's see what that looks like. So again, we start off with a component, chart component. It has an SVG element in its template. And so what we do is we need access to it. We need access to that element so we can call the third-party library on it. And Angular has this very nice way of doing that by providing decorators called viewChild or viewChildren, which basically allow us to declaratively, or actually imperatively in this way, access elements or even directive or component instances using these decorators. So what we can do is we extend the markup with this hashtag chart, and then you can access it using the viewChild decorator like that. And it's an element reference. You can name it whatever you want. It doesn't have to be the same name. You can also do hashtag chop chop, and then call the property still chart, whatever you want to do. And then the next thing we want to do is, in order to actually access that thing that we've just fetched using viewChild, we need to wait until the view is initialized, because that's actually when it's happening. So we can't just call this chart in ng on init, because it's just not there yet. We need to wait for it. So there's ng after view init, which is a lifecycle callback that we can implement as well in TypeScript. You don't have to, but it's nice. And then we know the chart object is actually initialized. So we have that element reference. And then the same thing. We calculate the data using the positions that we have. So this is an input, basically the boxes coordinates that we pass to that chart. We kind of pre-process the data so we can send it to the chart. And that's it. That will give us the initial render. The next thing we need to do is we need to update the chart whenever we drag and drop a box. How do we do that? So the problem that we have is that since we have this list of positions generated in our application, this list itself doesn't really change, right? The reference stays the same. We do drag and drop a box, and the x and y values, they change, but the collection itself doesn't change. which means is that the positions that we actually have as inputs, they don't really change. So we can't use the ng on changes lifecycle callback to be notified when there's a change in the collection, because the collection itself doesn't change. So how do we do that then? Well, there's another lifecycle callback called doCheck, ng doCheck. It's basically a method that you can implement, and it's always executed when change detection is performed. And this one basically lets you perform change detection yourself. So even if you know positions itself hasn't changed, you can now go ahead and then check if maybe items of these positions have changed. Right? So we do exactly the same thing here. So we calculate the data again with these positions. And at this point, you actually really want to find out if there are changes in the positions or not. This we can do as well, but it requires a little bit more code. But then this would be the moment when you would update the chart with the new data that you've just kind of pre-processed.
And please notice it's almost the same as in React.
Yeah, it's pretty much the same code, right? So here's the demo. This is the Angular version. I can drag and drop the box, and actually, as I'm dragging, you see how the chart is updated, right? Pretty cool.
Wrapping it up, right? So almost on time. So I was again surprised how similar it was. The access to the reference element is a little bit different from React to Angular, but other than that, the name's a little bit different. The mechanisms are like almost the same. So pretty nice stuff. Okay.
Okay, yeah, so conclusion. So what do we say? Well, so we learned, like I learned a lot from him. I learned a lot about Angular by learning a bit of React and probably also the other way around. So that's nice. We can learn from each other. We are friends learning from each other, right? Daft and Punk. We learned that Angular and React indeed have similar solutions to solve the same problems, which is nice. So if you learn one or the other framework, you can take advantage of that in one or the other framework. And then also, we can basically tune or change the behavior of both frameworks in a similar way, although I would say that in Angular we have a couple more options that we haven't shown yet, but if you're interested in seeing some more performance optimizations with change detector references and stuff, catch us after the talk. But after all, it's kind of the same for if you want to solve like your regular problems on a daily basis. Last but not least, yeah, kind of a comparison that Angular is more like a full stack thing, whereas React is more like a view layer kind of thing. So
and both can be either good or bad depending on what you want, right? I mean.
Right. So Angular gives us like things like forms and router and animations like out of the box. It has an opinion on that. React doesn't really have that. There are like many different community projects that you have to rely on, which is, I mean, it's a good thing, but you need to find those things yourself. So depending on what you want to do, depending on what project you work, you might want to have an opinion or not. Right, and before we close here, we would like to thank a couple of people in the community who made this talk possible. So there are people like Patrick and Tobias from the core team, and Wasim and Jeff who are working on the Universal project, and they helped us understanding what's actually going on there so that we can actually tell you what's going on there. So without these people, this wouldn't have been possible. Thank you very much.
Thanks.